Okay. Yeah, good day. So today we'll be looking at analyzing data using GraphPad. So the data I'm considering today is actually data concerning biological sciences. When we design an experiment in order to check the effect of a plant or herbal extract on diabetes, on hypertension. But today we'll be focusing on diabetes. So let me open GraphPad. This is my GraphPad. My GraphPad. So this is GraphPad. So because of most of the research we do in biological sciences are group data. So you're going to select group, then enter replicates. Usually, when we design an experiment, we look at the grouping. So we can have group 1, group 2, group 3 to group 5. Each group will contain maybe 5 to 10 rats, but let's use 5 for the case of this study. Create. So we'll create a data table like this. So what we have here, we have the group A, which will be normal control. Normal control, the group that there is no induction of a particular disease, but since we are looking at diabetes, so in this case there is no induction of diabetes. Group B, we have diabetic control group, where there is an induction of diabetes without treatment with a standard or maybe herbal drug or any standard drug. So here we induce the diabetes to the animals either using alloxan or streptozotocin. Group C, we have diabetic control standard. In this group, we induce with diabetes and treat with a known drug. Either we use metformin or glibenclamide. Group D, let's use that for a particular study we did last year, which we use polyherbal formulation. So this polyherbal formulation, we have different herbs that we put together to have the extract. So I have a polyherbal formulation. So let's say low dose of the polyherbal formulation. Group E, we have the same polyherbal formulation. In this case, we're looking at the high dose of polyherbal formulation. So I actually have let me open this. I actually have data from here. So let me copy this. So Ctrl C to my GraphPad. I have take it back to normal control. I have Ctrl V. So this is so hard. You notice that the blood glucose of the normal control is within the normal range, while the blood glucose of the diabetic control is high. You can see we have 200 something. For group C, we have a reduction in blood glucose, which should be normal. So if we were to analyze this data, we'll click analyze. You'll notice one way ANOVA have actually been highlighted, which tells us that we're actually we are analyzing variance with respect to grouping. So we have different group, up to 5 groups. That's why we're using one way ANOVA. If we had been 2 groups, we would have used the t-test. So click OK. Okay, you have each row represents measure data. Click. So we're comparing between groups. Yes, we're using ANOVA. Let's look at multiple comparison, because we might be interested in comparing between the normal control and the treatment groups. We can also compare the diabetic control and treatment group. So we want to do a multiple comparison. So in this case, we compare mean of each column with the mean of every other column. So this will click. Then we look at the option. You can see 2 keys recommended. We can use Bonferroni, you can use CDAC. So, but usually you can see 2 keys already recommended for a study. So we'll click the 2 key recommended. We'll look at additional results. We'll look at the descriptive statistics to get the mean and standard deviation. So show the significant digits for every except p-values. So we have the p-values of 4 decimal places. So we'll look at, okay, this is good to go. Click OK. Our data will analyze. So we have the ANOVA results. As you can see here, the ANOVA results. We have the multiple comparison. You can see in the multiple comparison, we are comparing between normal control and diabetic control. You can see there's a significance. So the significance tells us the difference, if there is a significant difference between the treatment group. So you can see here we have normal control and diabetic standard have a significance. So we can here you can see, okay, let's compare between the diabetic control and the polyherbal formulation. For high dose, we have a significant difference. But here you can see the summary of the significant difference. Here we have 4 stars, we have 2 stars, we have 3 stars. So this star tells you the degree of significance. So we can actually go to the data table to get the graph of our study. You can see, you can have, okay, this is an individual data. No, what we need is the summary data, which gives us the mean plus or minus standard deviation. So this is what we get. We'll click on this. So you can see the plot is actually expressing the mean with standard deviation. We'll click OK. So you can see we have our data like this. So here we have, you can actually, make this, look better. Delete, because since we actually have the keys on the x-axis, delete. So you can see we have here. So this is, here we can actually have the treatment. We have the treatment group. Here we have blood glucose concentration, which will have glucose brackets, which is expressed in milligram per dl. Close. So this is what we have. This is our graph for this study. I think in our next video I'll look at how to use the significant differences to make the graph look better understandable, or look understandable. So we have, you can actually beautify your graph, which is not the essence of this class. So I believe I'll end it here. You can actually right click to copy your graph and paste it in your Microsoft Excel, Microsoft Word for your results section. So thank you. Do not fail to subscribe to my YouTube channel and share with your colleagues. Thank you very much.